There we go. So yeah, Linters for fun and profit. I have to say this kind of a random title, which was kind of a rip off some of other presentations I've been to. So apologies if you are one of the authors of those talks. But for starters, yeah, basically Linters and what they are, it's going to be kind of a quest through stories and about code quality as well, because Linters are associated with code quality most of the time and compliance. General topics, again, briefly what linters are, 3-minute history. I'll try, you don't put a kind of a stopwatch on that because I'm not sure I'll hold the 3 minutes, be less or more. What linters are, so basically, so static analysis, I'll show you a little bit about what the existing ecosystem is around Go and static analysis. And as well as a kind of a medical warning of the side effects of heavy use of linting and what it can actually bring you, hence the profit in the talk title. But for starters, linters, WTF. Linters are a nice story, and as all good stories, they start with something interesting, sheep shearing. And this is not a joke. If you go back into the origin of the word linting, it comes from lint, which is basically to remove the fluff from the fabric that you created out of wool. So that's literally the origin of the word linting. More technically speaking, because we are after all at a tech meetup in Golang people, lint was a Unix tool that was created to basically optimize your C code back in the 70s, end of 70s, early 80s. It was mostly focused around performance recommendations. It detected things that were suboptimal. The reason behind the need of that tool was, at the time, compilers, unlike the awesome Go compiler and other languages compilers we have nowadays, were not that powerful back then. Like, they were basically running behind the machine, and just changing a few elements in your code would basically result in vastly different performance of that same code. Nowadays, you can basically fed a lot of different things and different ways of doing the same thing in a language to the compiler, and the compiler will still spit out kind of the same optimal code, especially if you tweak the optimization flags, especially, well, for the C language and C family languages. So yeah, it was mostly performance-focused recommendations because, well, people were still trying to do high-performance computations even back then with scarce resources, only single cores and very low frequencies and not much memory. However, as time went by, as said, compilers started to take over those responsibilities. They were becoming better and better at optimizing code, even if you did written in a suboptimal way. And lint-like tools actually started to evolve. They didn't just disappear because they were no longer needed. They basically started to detect other unpleasantness because the kind of static analysis, that's where the term comes from, that you can do in code doesn't just uncover performance, it can also uncover non-performance critical issues, but still fundamental issues with your code, or things that could be dangerous, like undefined behavior, which for people in C is kind of the bane of your existence. So we're fast forwarding to the present. So linting is not, well, barely performance related, although even Go has some performance related linting, but it's not just for C-like languages. You can lint Java, Python, Haskell, Docker files, YAML, even JSON in some way will type check basically if it works, because linting is quite vast. It can be just be formatting like gofumts, or if you prefer gofumts by M. Vedan again, as a more stricter tool, but there's a lot of different things to it. Static analysis itself, which basically linter does, analyzing your code without running it, is an entire research domain by itself. It's a quite vast one, because if you just look in a famous computer science research library, it gives you over 20K hits just for 2019. So that, by many definitions, that's pretty vast. And that's kind of the 3-minute history of linting. But yeah, static analysis, and you'll notice me, I'm going to refer to static analysis now, not linting. Linting is just running your static analysis over the code and getting the results. And a linter is a tool doing static analysis. But what about Go, which is kind of a most interesting and most foremost concern here? Static analysis basically, and obviously this can be debated, is a pattern matching on a code's representation. The idea is that if you have an accessible code representation, so an easy way of basically having a computational and algorithmically easy to understand way of representing your code, that means you can do an easier pattern matching or easier static analysis. So if you have easier static analysis, it also more likely people will produce more of it and actually make it more useful and more productive for its outcome. And basically go follow that path, not just for that reason, but for many others as well. Because guess what? Go has many different things to actually allow you to understand the code representation of your program. You have Go AST, which is the abstract syntax tree, AST. It's kind of a classical thing of how you represent the code. It's literally an algorithmic tree. You have Go parser, which will go run over your code and together with Go token, understand the different tokens or words in your code and signs and transform it into an abstract syntax tree of your code. And many other things. I'm not even enumerating all the packages, but those are just in the standard library ones. Beside of that, there's general first and third party tools as well that actually are higher level and help you even more develop your code analysis. Basically doing most of the hard work and the heavy lifting on the hood for you, where you basically just have to write the padding matching part of things and not the parsing or even the understanding of the code. In that sense, here again, just a few of those paths of those packages that you can import. The documentation is pretty profuse, although it can always be better. That's a caveat, but do have a look at them. It's pretty easy. So with that in mind, writing static analysis tools is pretty damn easy in many cases. However, that is not really the thing why I was talking about this, because there's already many excellent talks on the subject. I just posted 2 of them here. The slides will obviously be available after the meetup, and you can actually click those blue links. But the most recommended one is actually a recent one from last year, GoverCon SG by Michael. It was basically, it explains to you in a very 20-30 minutes, very easily, how you can write your own static analysis. And it really helps people understand it's not just this, oh, I need to know everything about compilers or about code representation or all the small details of a language. No, it's really, really easy. And or even beginners in Go can easily write an analysis of their own code and basically produce static analysis in that sense without actually with the help from all these packages, third-party packages that do the heavy lifting for you. There's a little bit more lower level one that I also could recommend. Was quite interesting when I looked at it, but this is, as I said, a little bit more advanced and low level, so less based on those higher level packages which didn't exist back in 2015. But still, you can still do more interesting, more complex analysis with the lower level packages. Also, kind of gratuitous punch here for the tools and static analysis channels on the Gophers Slack. If you're on the Gophers Slack, many people hang out there have written one, more, or tens or dozens of static analysis and checks, and you just join them and they're happy to help you out. I'll be there as well if you have any questions. As said, just a caveat, static analysis is easy. Obviously, it depends on the kind of analysis that you're doing. But moving on, again, not the topic, main topic, because there is already a vast ecosystem of linters, because it's easy to write them. So there is already a lot has been written, and it's developing more and more. So what happens if you start using it, and what do you get with it? So demo time. First of all, I'm gonna, if people are a little bit aware with the Go Please server, if you haven't, you can check it out. Many blog posts about it, developed by the Golang team. It's a language server that helps you type code and basically provide auto-completion and whatnot. As you see, I'm using VS Code, and I just started a simple project with a main file. And can basically start typing with it, because, for example, if I just want to print a string for something, so I can, what I say, I have or basically I'm going to write an int here, basically, sorry, my int variable, and I want to print that variable in this case, and do a little bit in a convoluted way. But basically, if I'm adding the fun package, and I want to print it now. So basically, if I add this now, and I'm going to type it here, basically, my int, I'm going to print it. Hey, I'm getting a...
Sorry to jump in, Duco. Can you make the text a little bit larger?
Yeah, sure. No worries.
So those glasses. Thank you.
Here we go. I thought I had done that before, but apparently not. Here we go, better. So as you see, we have a nice squiggle here that's provided by the editor. So actually, if we go over it, we also get, this is the Go Please language server that tells me this. We have a provisional formatting directive .s, but it doesn't understand that we were providing it with an int in this case. So that doesn't really match up. Actually, we can do it more explicit. If I just start typing here in this way, I already start squiggling before, while I'm even typing, and says, well, I need to give an argument to this formatting string, but I don't have any. So actually, if I complete this with, well, I'm going to give it a string here, hello world, and it already stops complaining. That is already static analysis. It gives you feedback while you're typing in this case, because it basically reruns it very frequently, and it does many different forms of analysis in this case, and presents you with hints of what you're potentially doing wrong, or your code might be doing something that you were not intending to do. So nice, that works good place. So what it is actually, so it's a Go please language server that is, in this case, using the third-party static check library, and amazing tool, a lot of various different checks in there. And it's available as a standalone tool as well. It's, in this case, it's kind of integrated into the Go please language server, where you can download it and you can build it yourself as well and run it against your code. But then again, there's a lot of check in there, but there might be more because, well, a single tool might not implement all the checks you ever want, although the authors might want to, they haven't achieved it yet. So what if you want more? What can you do? Well, there's not just one single, like I said, there's a vast ecosystem. There's not just static check. If I got a bit more pre-existing complex project, so basically this is a test function of something doing, I'm just going to make this a bit easier, doing many different tests. It's kind of a usual test case driven, table driven test. I iterate over my test cases, I run it. Although this is where the lack of interactivity in a virtual setting comes into play, but some people might see that there's already an issue in this test case. And a linter can help us detect that if we're ever right. So actually, if I use the lint function, because I have a linter configured in VS Code, run it right here, runs it. And you see, actually, I've got new squiggles appearing here. So what does it tell me? You're using the variable on a range scope test case in a function literal. Scope lint between the brackets is the name of the linter that's highlighting this. So what this actually tells me is that, well, if you're familiar with the Go syntax, if you're ranging over this case over a map, these two variables are not just iterating over the actual memory cases in the map. They are actually, every iteration, you are calling basically the same value, the same variable memory locations are being overwritten with a new key value pair in the map. And when you do that, then basically those same value memories places are passed into this function call of a subtest. Now, in this case, it would work because this run is not run in parallel. But for example, if I were to add a parallel test and iterate, and then those things start to run in parallel, and we get more issues. The squiggling is a little bit messed up, unfortunately, because of the typing doesn't really necessarily line up in life. But you can just basically rerun this and lint it again. So this could analyze the right positions. But what it tells basically this all the same tests, because of the copying and the overriding of the two variables here in their locations, I might be running as many tests as I have in my table, but they might all just run the same test case because I'm passing potentially the same value to all of these subtests, which is a bug in this case, and you want to prevent that. So again, the linter warns me to not do that. The good fix here is actually don't even need to remove the parallel, is to remove the test case because that's a complex structure that you can't just pass around, and define it right here as a nice pattern. And you look, in this case, you allocate a new variable for each iteration, and that means that the whole value in the map of the information of your test is literally copied into the underlying, basically into this new variable, which is again uniquely allocated for each of the iterations, and ensures that every single one of these tests will actually run the intended subtest case. It's a bit subtle, but I would have loved to actually show it by running, but due to obviously race conditions, sometimes it doesn't just show up, it just actually works, and sometimes it doesn't. It's a little bit more subtle than that. But yeah, that's literally one of the other linters, and there's many others. Just one linter example. If I actually go and look, you see here, due to the nice VS Code highlighting, that I actually many different linter errors can be found because I'm using a very strict linting setup in this case, which I'm getting to now because I'm running many. How do you run all these linters all together on your code? So again, managed static analysis exists. GoVet is pretty well known, part of the Go ecosystem, like the first party ecosystem, GoLint as well. ScopeLint, which I just introduced. There is StructCheck, which is a nice linter that basically tells you whether some of the unexported fields in your structures are unused, and which can just be deleted to save space and memory. Unused is kind of dead code analysis. If any of your code or any of your functions, unexported functions, are not used anywhere, you can just delete them. Go Critic is one of my favorites. It's quite opinionated. It's very configurable. It has loads of tests in it, but you can basically lint everything from style to code behavior, performance, and it has dozens of checks already in there, which so some of them are enabled by default, others you have to activate them, but it's all configurable. But again, if I want to run all of these, how do I do that? Because I just don't want to invoke 20,000 binaries to run all my tests. This is what you call use a meta linter. So a tool basically that combines many existing linters and runs them all separately, aggregates the results, and presents them to you in a uniform way. Just for historical reasons, I've shown the Go Meta Linter project, which was defunct for the past year or more. It has been superseded by a different project, which not the same author, but took over, was the Golang CI lint one. And these basically, especially the Golang CI lint nowadays, is basically have a lot of those linters vendored or built in so that you can actually you can expose all those different checks to you in a same uniform configuration format and a same uniform result type in this case. And there's literally Golang CI lint is the one I'm using here in VS Code at the moment, and it shows you many of the different things. My personal take on this is you can, not that all linters should be used, and again, they're all configurable. That means that configuration is important. Configuration means that you can be opinionated about things. You can be draconian or even masochistic if you really turn the dial up to 11 and get a lot of interesting results on basically warnings sometimes on things that you shouldn't be saying. I don't want to have warnings about what I'm doing here. This is perfectly right. But this means you can dial the level to which you want it to be enforced to a pretty precise level and things that suit you and your project. But yeah, what do we get when we apply this? So this is the public service announcement, kind of a medical note is what happens when you start linting aggressively. As you just seen in my demo, it's like linter feedback in your IDE is nice because it's pretty immediate while you code, and it actually, I can testify to myself, it improves your own coding style over time. Because you better understand each of those checks is another, each time a check shows up and your code is flagged as being problematic, it forces you to think about what is actually problematic here, what I'm doing with this code that I should potentially do differently. Again, linters can be more or less opinionated, so sometimes it just plain wrong what you're doing. Sometimes it's more a little subtle, as in it's more stylistic, as we prefer to do it this way, but you could do it in another way as well. However, this is just for yourself. If you are more than one working on your project, which is more likely in your work setting or even in larger open source projects, you run quickly into a different problem, which is quite well known by this XKCD, which is, well, many people have different opinions on what's going on and what you should be doing as a style. And basically, using this linter for yourself only gets you as far as yourself, as your own development reaches. What happens if you do it at project scale? So Go is an opinionated language, as I said. We have Go Fund, which is pretty opinionated. We have the Go proverbs, which I recommend reading, which are quite interesting, like ideas of what do you do, how to do specific things in Go. There's an idiomatic Go recommended read is a quite recent blog post by Dave Cheney, again, who was also quoted in the first presentation, who has pretty nice long thoughts about what is idiomatic Go or correct Go, if we can say so. But in this case, if we can enforce via linters how we achieve something, then any code review or discussion can be focused on what we are doing. And that takes away a lot of distraction from code reviews or any other general design discussions. Linters in this way can help basically focus your decisions, and just if you're doing something, it will tell you, well, this is how you're going to do it, but you can more think about what you're doing and why you're doing it. So it basically allows you to change the topic of your conversations with your fellow colleagues about like the real change that you're trying to implement with your PR or your project, and focus on that. Because verifying compliance with linters is just another test. So you can run it as part of continuous integration in your open source projects, especially of GitHub Actions or other platforms that basically allow you to, for open source projects, to just run CI for free and with very little setup. So what happens if you do that? I took it from a large project. This case kind of a little bit anonymized because it was a private company related one. this is a set of linters over a different time period historically. So the same linter configuration over different points in time that were run, and how many errors were detected by each of those linters in that project in the code base over time. I'm not going to discuss obviously all the different ones because then we have a 30-minute discussion. But what you can see literally is one of the most biggest outsiders is GoVet that actually triggered a lot. That's occurred, had a lot of different hits and reported a lot of different issues in the code base up to 9 months ago. And then it dropped, literally dropped through the floor, like divided by almost 3 the number of hits that occurred. The same for error check, which started to drop off almost 3 years ago, 3 and 2 years ago. That code analysis as well, like halved over more than 9 months ago. So these large drops in numbers actually correspond to the point in time where those linters were historically activated, when the checks were started to be enforced in that code base. As said, this is a retrospective view, so I've just literally reused the current configuration even on the past situations. But in the past, those linters were not enforced in continuous integration. So literally what we see here is that as soon as a linter is activated, you can actually see it dramatic because people are forced to change their files. Whenever you touch a file and it has a linter, past linter issues, now you have to fix them. And basically this allows you to increase your code quality significantly over time. But then again, this project has used a quite loose set of linters. You say there's many, there's already 2, 4, 6, 8, 11-ish of them, but that's not much. And especially some of the errors that they report might be silenced by a specific configuration. So actually, if you put a little more stricter linting, so in this case, the highest bar is at 600 hits. Actually, you can go up all the way to 1250 if you have very strict linter settings. And again, all these points are not necessarily errors in the code, but they are points of debates in your code quality on whether the code is actually being written in the right way. Again, right way between quotes. And in this case, you see, well, actually, the GoVet, although is still dropping, other linters, for example, the scope lint that I was discussing before, has actually exploded over time because that one was not enforced. It was not being checked as part of the regular configured linters for that code base. Last but not least, kind of things out, I'm talking about hit counts here. Hit counts are interesting because it's a raw number. However, over 3 years of history, a code base changes a lot. It might grow, it might shrink. So maybe a more representative metric here is the number of hits per lines of code in this case. So it's kind of a more averaged metric. And this is the converted one. So this is the average hit ratio. So the number of hits per 1,000 lines of code in this case. So you can see here that actually between, if we go back, if we look, for example, at the error check linter, or actually it looks like it decreases. Well, a little bit, but actually decreases much more vastly because there was a huge code growth without introducing any additional errors and actually removing some of them. So actually the effect was way more important. Again, this is just one example of adding linters in a more enforced way into a project. But overall, these kind of things and these kind of enforced checks have the advantage that you start really over time, and not just over one week or 1 month, you see significant improvements in code quality over time. Just like some people like to check for test coverage, linter coverage in this case is also a very interesting thing to look at. And it's not just only improves your own coding skills, it improves your colleagues' coding skills. And together, when looking at the results, you might actually fuel some interesting debates on whether you want to change some default style guide that you use on your project. As I said, that's about it. This is the end of the presentation with these kind of results. But I'm more than happy to take questions if there are any. Yeah. Stop sharing the screen.
Amazing. Thank you very much.